Well, now we're going to talk about writing recursive formulas. And so we can be writing either a recursive formula for an arithmetic sequence or a geometric sequence. We saw one earlier. It actually had both a geometric and an arithmetic feature in it. But again, we're being asked to write a recursive formula. So let's look at this first sequence on the left. So we got 4, 10, 25, and 62.5 is our sequence. And so the first thing we need to do is to determine whether we're talking about a geometric or an arithmetic sequence. And so let's see. First I'm going to see, does this look like, this one on the left looks like an arithmetic sequence? Well, 10 minus 4, that's 6, but 6 plus 10 does not equal 25. So more than likely it is a geometric sequence. So let's take this second term and divide it by the first term. So 10 divided by 4 is 2.5. And then 2.5 times 10 is going to give me 25. And then 25 times 2.5 is going to give me 2 times 25 is 50. Half of 50 is 12.5. 50 plus 12.5, yeah, 62.5. So now when I write a geometric sequence, I define what A1 is. And in this case, A1 equals 4. And then, let me just write our formula here for the how the sequence, then I'll complete it. We would say that AN is equal to the common ratio, which we said our common ratio here was 2.5, 2.5, times a to the n minus 1. And then we got to express our domain. So, okay, I've already determined that A1 is equal to 4. So then AN is equal to 2.5 times a to the n minus 1. And my domain is such that n is greater than or equal to 2. In other words, an n representing the number in the sequence. And then I can take this formula and find that sequence. All right, well, we've done the one on the left. It's a geometric sequence. Let's look at the one on the right. 9, 36. Let's see, well, if I was thinking about geometric sequence, 9 times 4 is 36. 4 times 36. 4 carry you 2. Nope, it's not a geometric sequence. So let's see, 36 minus 9 is 27. And then 36 plus 27, 7 and 6 is 13. Carry your 1, 3, 2, 63. Yep, and we'll just go ahead and verify the next piece. 63 plus 27, 0, carry 1, 7, and 2 is 9. 9. So it is an arithmetic sequence. We have a common difference of 27. So, our basic formula for developing an arithmetic sequence is AN, we should remember this from a previous lesson, equals AN minus 1 plus D. Now in this case, A1 is equal to 9. And then, so therefore, we can finish this off by saying that AN is equal to AN minus 1 plus the common difference, which in this case it is a positive 27. And we're going to define our domain that AN is greater than or equal to 2. Now, why is it greater than or equal to 2? Well, it needs to be that because then our first number here in the sequence would be the first number. All right. Well, we've done it. We've written recursive formulas.